This video we're going to look at how we can use De Moivre's theorem for our complex to integrate powers of sine and cos. And in this one we're actually going to be integrating powers of sine, but it could easily be manipulated, as you will see. Okay, the question says express sine to the power of 4 theta in the form d cos 4 theta plus e cos 2 theta plus f, where d, e and f are constants. Okay, so I've already done this out because I've made that many mistakes doing out this video. So I've just done it out and then I'll talk through it. The first step of this is very similar to your last video, is you let z equal cos theta plus I sin theta. That's your basic definition of complex numbers. And that means by De Moivre's, z to the minus 1 is cos theta plus I sin theta. Now if you subtract those two things, you're going to get z minus z to the minus 1 is equal to 2I sin theta. Put that in brackets, just makes it a wee bit easier going forward. Or if you'd added them, you would get z plus z to the minus 1 is equal to 2 cos theta. Now what we're doing here is we're going to find what z minus z to the minus 1 to the power 4 is. Now if we skip down a wee bit, that's what your z minus z to the minus 1 is. It's 2I sin theta. So remember, we're trying to find z to the power 4. So that's what we're doing here. So this thing really is 2I z theta, and then to the power of 4. That's what we're doing here. So when you expand that, and I expand that using my Pascal's triangle, just do that out to show you where that comes from. And if you don't like Pascal's triangle again, you can just use your NCR button on your calculator, but I find Pascal's triangle very quick and easy to use. So there's my Pascal's triangle. So my first term, when you expand this thing out, you're going to get z to the power 4 plus 4z cubed, then the minus z to the minus 1, and then plus, my next coefficient is 6, z squared, then minus z to the minus 1 to the power 2 this time, plus 4z times minus z to the minus 1, now it's cubed, and the last term is just 1 times the minus z to the minus 1, and it's the power of 4. When you do that out, that's what you get. And then the next thing you want to do is you want to group these. So you group and put them in a bracket, your z to the 4 and the z to the minus 4. So they're together. And then you've also got the same with your z squared and your z to the minus 2. And then you've got a plus 6 on the end. Now, where this next bit comes from, and again, this came up in the last video as well, we know that z was equal to cos of theta plus I sin theta. So by De Moivre's, z to the power of n is cos n theta plus I z n theta. And then z to the power of minus n is cos n theta minus I sin n theta. And again, if you add those, we get z to the power of n plus z to the power of minus n is 2 cos n theta. Now we did that, we added them because look above then, we've got the z to the power of something plus z to the power of that minus something. So that's what you've got here. So this whole line up above, we could rewrite the z to the power 4 plus z to the minus 4 is just 2 cos 4 theta. The z squared plus z to the minus 2 is 2 cos 2 theta. And then on the left-hand side, the z minus z to the minus 1, remember I said earlier on, it was 2I sin to the power 4 theta. So that's what you've got. Now working down to the next line, working down to the next line, you've got 2I sin theta to the power 4. 2 to the power 4 gives you the 16. I to the power 4, let's just look at that. I to the power 4 is I squared, and I squared is minus 1. Minus 1 squared is 1. So there's where your I to the power 4 just becomes 1. And then so it's 16 times z to the power of 4 theta. And over here, 2 times the cos 4 theta, dead easy. Then minus 4 times the cos 2 theta is just minus 8. And then you've got your plus 6. And the last line, bring the 16 across and divide, and you'll get z sine to the power of 4 theta is equal to 1 over 8 cos of 4 theta minus a half cos of theta plus 3 over 8. Okay, so that's the first part done. The next part of this, what you had to do is you had to integrate this thing then. So you had to integrate this, and it says hence integrate that. So you must use what you've done before. So you rewrite your sine to the power 4 of theta, and then as 1 over 8 cos 4 theta minus a half cos 2 theta plus 3 over 8, and integrate that with respect to theta. So when you do that, and remember this is how you integrate cos m theta, you get 1 over m sine m theta. So when you integrate that, you'll have 1 over 32 cos of 4 theta minus 1 quarter sine 2 theta plus 3 over 8 times theta. And that's integrated. Remember, your limits are 0 and pi over 2. So the first bracket here is what I get when I put in pi over 2. So it's 1 over 32 times sine of 2 theta minus a quarter times sine theta plus 3 pi over 16. And then put 0 into it. Sine of 0 is just 0. Sine of 0 is 0. And 3 over 8 times 0 is just 0. So it just goes to 0. So happy days. Next line, this thing just becomes 0. This thing just becomes 0. So use your calculator button and radians mode just to check that if you need to. And then you've just got this. And then my end result is that whole integral just becomes 3 pi over 16. And that's us. That is us done.